Okay, so after having talked about SFM10 in the previous video, it is now time to talk about MVS10. So MVS stands for multi-view stereo. Yeah, don't think too hard about why it's called multi-view stereo. I'm not sure myself. It's more like photogrammetry, basically. But MVS10 cannot work without SFM10. So SFM10 and MVS10 are like partners. So to get MVS10 working, you need to have SFM10 because SFM10 computes the camera poses for the set of images that you provide. So you need SFM10. So you run SFM10, you get what SFM10 outputs, and then you run MVS10. Okay. So MVS10 by itself is nothing. You need SFM10. Okay. Okay, so MVS10 builds a dense as opposed to sparse reconstruction of a 3D scene from a set of pictures, photos. Yeah, so either taken with a camera in photo mode or extracted from a video. Let's look at this. So if you go to the we need to get the manual, then everything is explained. So let me explain to you how you get there. So you have to go to the 3D software page, which is here. So so this is the 3D software page. And what you do is that you go down. You keep going until you see 10. So here you see 2, 3, 4, 5, and they're all in archives. And you just get to, you keep going until you see 10 here. So this is MVS10, but we are interested in the archive. So let's click on this. So this is an archive that's sitting on Dropbox. And what we want is the manual for MVS10, which is this one. So you can just click on it. You don't have to download anything. But to make things easier, I previously downloaded the manual, and it's sitting here. Manual for multi-view stereo 10. Okay, so let's look at the workflow. So it's showing the workflow, the pipeline. So the input is a set of images assumed to be taken by the camera. And we assume that SFM10 has already been run. So we know the camera poses. So we know the rotation and the translation of the cameras. So for each pair of images, you consider each pair of images. So if you have like images number 0, 1, 2, you would consider pair 0, 1, pair 0, 2, and pair 1, 2. You consider all the pairs. So you rectify the images using a rectifier. I use my own called ER9B. Then you compute the disparity map, the depth map, using a depth map generator. In my case, I use DMAC5. And you add the matches, so pairs of image points coming from disparity map to the 3D reconstruction. Then you remove the image points for which the reprojection error is too large, and you remove 3D points, also known as tracks, for which the number of image points is too low. Usually you want at least 3 image points per 3D point. Let me explain. Yeah, I'll explain later, I'm sure. I'll get back to that. So you perform bundle adjustments on the 3D points. So that's standard stuff. And that's pretty much it. So the output of MVS10 is, okay, so this is just to play around. So a set of frames named the_XX. So it goes from 00 to 11. From that, you can use GIMP to create an animated GIF if you want to do a wiggle. But more importantly, it's creating a point cloud in PLY format named the.ply, which you can load in MeshLab or Cloud Compare or whatever else you want to use. If you know of alternatives, let me know in the comments. Anyway, you can mesh that thing also if you can, like the Poisson method. I know it's available on in MeshLab. I'm not sure about Cloud Compare, but anyway. Okay, so here I'm talking about the directory MVS. Okay, so before I forget, the reason I'm making this video is mostly because this code, the MVS10 code, is now available on GitHub. So I'll put a link to it, of course, in the description, but here's the code. Okay, it's not that much, but it's relying on put that on the dependencies. So there's a command repo which I have lots of tools in there. So DMAG5 is the def map, ER9B is the rectifier, and SFM10, of course. So let's just go into the main and the test. So there's tons of files here. But basically what you do is that, so you create a directory where you put your images, and first you run SFM10. So to run SFM10, you're going to need sfm10_input.txt, which is the input file for SFM10. So you run SFM10, and you're going to get a bunch of output files. And what you do is that you then run MVS10, and you only need one file on top of the ones from SFM10. And that file is MVS10, which is buried here. So this is the input file to MVS10. Okay, and those are all the parameters, which I'm gonna explain next. So let's go back to that PDF with the manual. Okay. Okay, so here I explain what I've just said. And here I'm explaining the format of the input file. Okay, so file name for NVM file should be called, that comes from SFM10. It should be the.nvm. The three next parameters relate to camera pair selection. So it's the maximum number of matches, maximum mean vertical disparity error, and the minimum average separation angle. So why do you have that? It's because a priori you are considering all possible pairs of images. But many times the pairs, the two images in the pair are going to be very different. Well, it's not that it's not going to be very different, but it makes no point. It makes no point trying to get a depth map out of it, because they are too different. Okay, they are not looking at the same things. So it makes no sense to try to create a depth map. So that's why I have those three criteria in order to discard potential pairs. And I'll explain. So let me go through the list. This radius, alpha, truncation, epsilon, disparity tolerance, all this is related to disparity map. So if you know DMAC5, those are the parameters for DMAC5, the depth map generator. So it's all about depth map computation. Okay, so then you have 12 sampling step, and then again you have 3 more parameters, which is for the removal of low confidence 3D points. So, and we had those, the first two in SFM10. So you have a minimum separation angle, maximum reprojection error, and a minimum number of image points per 3D point. Minimum number of image points per 3D point. And then the last two is for the animated GIF. Pixel radius, amplitude angle, not a big deal. So let's try to go into more detail. Yeah, so the first three, I just explained that quickly, but it's to see if you actually need to compute a depth map for a given pair. Yeah, there's no point wasting CPU time on image pair that will not be particularly useful in the 3D reconstruction. That's correct. So you have minimum number of matches. By default, I think it's 100, which is fine. So that you should. Okay. If the number of matches is too small, it means that the two images are not. It means that the two images are not really looking at the same thing. So there's no point computing a depth map for that. Okay, so 100, good value. Then I look at the maximum mean vertical disparity error. So, if you have a pair of images that have enough matches, what you do is that you rectify the two images. So you align them using ER9B. Okay, so this is the graphical representation of that. So you have your two images. Here I have, let's say, two matching points before rectification. I rectify, so you get distortion. And now the 2 points should be aligned or on the same scanline. But there's always some error, and this difference, the Y difference here, that's the vertical disparity error. And what I do is that I take the average, and I don't want, I basically reject the pair if the average vertical disparity error is greater than the threshold I give in the input file. Okay, the maximum mean, yeah, so the maximum mean vertical disparity error. Okay, so, and here I explain, blah, blah, blah. So by default, I think I use 1. Yeah, so 1. You can probably use 2. Okay. This kind of guarantees that you're going to create a depth map that's not, that's kind of correct, that has a good chance of being correct. And then you have that the separation angle. Yeah, and I think I explained that when I made the video about SFM10, but I can explain again. And here I'm considering an average separation angle, because here I'm considering whether or not I should process that pair of images. So let's look at the separation angle. So you have your pair of images. So that's image 1, image 2. Okay, camera center, camera center. You have your 3D point. You fire the ray from the 3D point to the first camera, the second camera. That gives you an angle, which is called a separation angle. And you don't want that separation angle to be too small. If it's too small, then there's no point creating a depth map. The disparity map is going to be useless. So if the average separation angle is below the minimum average separation angle, the disparity map is not computed. So I like to use 0.1. Okay. And if you use 0.0, it's ignored, of course. Okay, so then he's talking about the DMAG5 stuff. So that's now pure depth map stuff. Radius, alpha, usually it's 0.9. Truncation value for color, 20 or 30, yeah, it's nice. Truncation value for the gradient, good value is 10, but it can go as low as 2. Epsilon is the smoothness, so good value is 4, that's right. Disparity tolerance, okay, so this is just to do, yeah, because I compute two disparity maps and I compare the disparities. And the disparity tolerance, so if you say that it's 0, you want the two disparity maps to match exactly. Okay, downsampling factor. Okay, downsampling factor controls by how much the images are reduced in size prior to computing the disparity maps. So I think a good value is probably 2. So that reduce the size of the image by a factor of 2 by 2, which is 4. But sometimes, like I think in the test case in GitHub, I use 4. It's just a matter of speed. But I think 2 should probably be better. It depends on the size of the images. If it's too big, you may want to use 4. Okay, then we go into sampling step. It controls how dense the reconstruction is going to be. Yeah, so if it's set to 1, it means that each pixel, you consider each pixel. If the sampling step is set to 2, you go every other pixel is considered. Okay, so yeah, so the lower the sampling step, the more 3D points you're gonna get. Yeah, so yeah, I'm saying the sampling step should be always set at 1. Okay. And okay, so now the next 3 is to get rid of bad 3D points. So again, you use a minimum separation angle. You use the maximum reprojection error. So this I explained in when I made the video about SFM10, but you can also look at the SFM10 manual, which is in the same archive as the MVS10 manual. And then the minimum number of image points per 3D points. It has to be at least 3. Usually you just set it at 3. That's fine. So if you set it to 3, it means that a 3D point must show up in at least 3 images to be considered reliable. Okay, and then the pixel radius and the angle amplitude, it controls the animated GIF frames. So, okay. Oh yeah, I showed the reprojection error. Okay, so basically, okay, so this is your photo or image, and this is the camera center, the corresponding camera center, and you have a 3D point, and that 3D point is part of your 3D scene, and that 3D point has coordinates in this image called UV or XY. Okay, so it's here. But when you reproject, when you fire the ray from the 3D point to the center, you may get a different value. So different UV. So that distance is the reprojection error. So if you have a 3D point So that 3D point is going to be known by this image, but it's probably going to be known by at least two other images. So if the reprojection error in any of the images is greater than whatever threshold you set, then you're going to assume that the 3D point is not reliable and you're going to get rid of it. Okay, so here I'm explaining a detail. But if you change a parameter in the input file, the program may not have to recompute everything. So that's what I'm trying to explain here. So depending on what parameter you change, you may have to delete the MVS files so that things can get recomputed, and I'm explaining that in the manual. Yeah, so here I explain where the depth maps are stored and blah blah blah. Okay, so let me tell you also that this thing is not particularly fast. So that's why I don't recommend using a lot of pictures, like 5, 10, 15, maybe up to 20 images tops. And the size of the image is probably 2 megapixels tops. And this is where, I mean, this stuff could be improved by quite a bit if you use, parallel processing and all that good stuff. Okay, so then I show the output, the end of the output when running on Windows, and this is what you see. So here, for instance, you get the number of 3D points, the average reprojection error, the max reprojection error, all kind of stuff. Okay. Okay, so let's go back. Let's go back to, yeah, okay. So here are a few examples. So here, the input is 3 images, only 3 images, okay? About 1 megapixel. Extracted from a video. So this is the sparse 3D reconstruction obtained with SFM10, okay? And this is the dense 3D reconstruction obtained with MVS10, okay? Another example, this one has 8 images, same size. So the sparse reconstruction, dense reconstruction. Another example, again 8 images, sparse, and this is the dense. Okay, and then I have a tutorial also on YouTube that I made before. Okay. What else did I want to say? Okay, so now how do you... So we know that the output of MVS10 is a point cloud. So what you can do is that you can go on Sketchfab, create an account, and you can load those point clouds into Sketchfab. And what you do first is that you zip the point cloud, because those things are humongous. And here are a bunch of examples I made over the years. Let's look at them. Okay, so this is Sketchfab, so that's my repository, I guess, my account, Go Capeto. So let's look at what I did there. So here's one. Let's see the size of it. Hold on. 1 million vertices. I don't remember how many images I took, but not many, like 5 or 6 tops. So this was taken in Albany, New York, at the museum there. So it's 2 oboes. making a meal or something. Okay, let's have a look at another one. Let's see what I did. Adrian. Let's look at that one. A bust of Adrian. This one, I think, yeah, I must have taken the pictures at the MFA in Boston. Okay. Again, not many pictures, maybe 5. Okay, so I think I'm going to stop here. Let's go back to this thing. Yeah, I'm going to stop here. If you like this kind of content, please like, comment, subscribe, and I will make more. Bye.